Welcome to Sarasota County Fire Department's Apprenticeship Program. Today's topic, Basic Pump Operations. The purpose of this presentation is intended to show the basics of pump operations. It is not intended to replace the hands-on training required to be proficient in this skill. The objectives for this presentation are to learn the different components of the pump panels, what they do and how they're used, to be able to identify different nozzles, appliances, and hoses, and to be able to determine correct discharge pressures. Let's start with the pump. On the pump panel, you will find a pump rating plaque. This will tell you what the pump is rated for in GPMs. It's also important to know the amount of water carried on your truck so you can calculate how long your tank will last. There should be a plaque on the pump panel showing the amount. If not, you need to find out. In this department, we have two different types of pump panels: midship or crossover, and the side panel. While they look totally different, they both have the same functions. Now let's talk about them. The tank-to-pump valve is used by the operator to supply the pump with the water stored in the tank. Remember to shut this valve when you have a secure water supply. If not, you'll end up using the water out of your tank. Tank-to-fill valve fills the water tank back up once you have a supply. It's important to remember to keep the tank filled in the event you lose the supply line. The throttle increases or decreases the RPM of the engine, in turn increases or decreases the pump discharge pressure. The pump pressure gauge indicates the maximum pressure you're getting out of the pump for that given RPM. Discharge valves correspond to the discharge ports around the truck. Make sure you verify the correct valve for the port the hose line is attached to before opening any discharge valves. Discharge gauges show the pressure on the individual ports. Use these gauges to gate down hose lines in the event multiple hose lines have been deployed. Water governors and pressure relief valves. Both are designed to prevent overpressurization of a hose line, which could possibly cause firefighter injury. The water governor works by RPMs. Once the water governor is set, the computer will decrease the RPMs if it senses an increase in pressure. The pressure relief valve is a mechanical valve and works off spring pressure. When the pressure increases beyond the setting of the relief valve, the spring pressure is overcome, causing the water to be dumped back into the intake side of the pump. Intake valves are typically located next to the intake port. Opening the valves with a water supply hooked to the port will allow water to enter on the intake side of the pump. The intake gauge shows the water pressure coming into the truck. This being a compound gauge, will show either positive pressure or vacuum pressure measured in inches of mercury. Cooler valves are valves used in the event of extreme engine temperature. Some water from the pump is diverted around the engine cooling system to assist in the cooling. When there's high pressure on the pump, just crack these valves to prevent damage. Bleeder valves are designed to take the pressure off of the hose to assist in draining the hose line. Work these valves slowly, as there may be a lot of pressure on them. These valves need to be kept closed during pumping operations. Now that we've talked about the functions, let's take a minute to view their locations on the two different types of panels.
Protect the public, that's my desire. Back of my shirt says Tulsa Fire. I take a good look around. I keep a close watch over this town. Gotta make it right, gotta go a little higher. American firefighter, American firefighter. Might be a house, might be a wreck, could be a baby, might be a pet. Yeah, we're prepared to make them all, ready and able for the next call. Gotta make it right, gotta go a little higher. American Gotta go a little higher. American firefighter. American firefighter. We stick together through thick and thin. They might need me, I might need them. As the heat gets hotter, we fight to win. I walk away alive, alright. Gotta make it right. Gotta go a little higher. American firefighter.
Engaging the pump is pretty much the same throughout all our engines. Okay, you've pulled up on scene. You've placed the vehicle in the best possible vantage point. You place the transmission in neutral, set the parking brake, and wait for the RPMs to drop. Waiting for the RPMs to drop is important. If you don't, you could possibly damage the pump. Engage the pump, place the transmission in drive, and please don't forget to place the wheel chocks. Okay, now let's put it all together. With the truck positioned to the best advantage, place the transmission in neutral, engage the brake, wait for the RPMs to drop, engage the pump, and switch the transmission to drive. Carefully exit the vehicle and proceed to put the wheel chocks down. You'll find one of two types of throttles on the pump panels, either the older manual type or the newer automatic type. The manual type requires the operator to turn the knob in order to increase or decrease RPMs. Also, the manual type has an emergency stop button. Simply push the button with your hand and the throttle will return to idle. This should only be used in the event of an emergency. With the automatic throttles, the operator is required to first select the pressure mode. Then, by using the increase button, push and hold until the desired RPM or pressure is reached. In the event of an emergency, simply push the idle button and the RPMs will drop to an idle. Remember though, you must reset the mode before you resume pumping. These units are operated by a computer. There are no emergency backups, and the operator should keep an eye on the message center. Once on scene and the truck in pump, the first valve normally pulled or opened will be the tank to pump valve. This will allow water from your tank to enter your pump and you can start supplying hose lines immediately. With the tank to pump valve open, the intake gauge should still read about 0 or a little below due to the fact there's no positive pressure coming in. The intake gauge can be used to calculate available GPMs. Also remember, always keep the pressure gauge above 20 psi. Now, your tank water's running low, and you finally get a water supply. You can get that water into your pump one of two ways, either through the piston intake relief valve, the PIRV, which is used for large diameter hose, or the smaller 2.5 inch intake, which can also be supplied with a 3-inch line. If your supply line is a large diameter hose, you must use the PIRV valve, the piston intake relief valve. Due to the fact large diameter hose can trap quite a bit of air, it's important to bleed the air off by using the bleeder valve on top of the PIRV valve. Once the air has been bled out of the line, close the bleeder valve and open the intake valve. If your supply line is 3-inch, connect it to the 2.5 inch intake and open the valve. As soon as the water supply has been established and you've readjusted the pressures, it is important to remember to start refilling your water tank using the tank to fill valve. This tank will be used in the event you lose water supply. If this happens, the operator must notify command immediately, and a transition to the water tank must be made. Let's talk about cavitation for a moment. Cavitation occurs when you try to pump more water than is available. It also occurs if air enters the pump. The sound a pump makes when cavitation occurs is very distinctive, and some say it sounds like rocks in a dryer. Although I've never personally heard the sound rocks make in a dryer, believe me, you'll be able to hear the cavitation. Cavitation, if left unchecked, will damage the pump. To prevent it, reverse the last action that you just performed. Make sure all intakes are fully open. Slowly decrease the pressure of the last hose line opened, or lower the RPMs. But remember to always keep the intake pressure above 20 psi residual pressure. The following clip will show the pump operator pulling the tank to pump valve and increasing the RPMs. As a pump operator, it's important to know the capacities of the hydrants. These are marked by the colors on their bonnets. When hooking a hydrant, it's important for the driver to go past the hydrant about 20-25 feet. This will make it easier for the hydrant operator to get the equipment from the rear of the truck. As a hydrant operator, you'll need to grab the LDH, the hydrant connection, hydrant wrenches, single gate valve, 5-inch spanner wrenches, and that all-important portable radio. Let's talk a little bit about wrapping the hydrant. Once all the equipment is off the truck, wrap the hose around the hydrant, making sure you're on the inside of the hose line, just in case the hose being laid gets snagged on the hose bed. Wave or radio the driver on, and once there's enough hose on the ground, remove the 2.5-inch cap and the steamer port. Before hooking anything to the hydrant, remember to flush it. Open the valve all the way till the water runs clean, and then shut her down. Connect the single gate valve and the hose line to the steamer port. If they're not screaming for water yet, let them know the hydrant is ready and wait for the go-ahead. Remember to open the hydrant all the way and to leave the hydrant wrench on top of the hydrant before you leave. Now let's put it all together.
When you face the fire, better get down. This is one time, friend, you'd better stay low to the ground and go alone or unprepared. Don't think yourself a coward if you feel a little scared, 'cause if you don't, there's something wrong. Control the fear and get it on, learn to survive. It will step right up, screech, won't shake your hand, just try to beat, you gotta stay alive. Stakes get pretty high, you either do it or you die when you face the fire. When you face the fire, only if you know, smoking gets so thick it tries to permeate your soul. Better know you are, better know where you've been, 'cause if you don't, I'm telling you, friend, it's on its way to win. Yeah, if you don't, there's something wrong. Control the fear and get it on, learn to survive. It will step right up, reach, won't shake your hand, just try to beat, you gotta stay alive. Stakes get pretty high, you either do it or you die when you face the fire. Show 'em what you got. Whatever you do, don't try to be something that you're not, friend. You never know till you feel the heat. If you need to be here or out there on the street, yeah, if you don't, there's something wrong. Control the fear and get it on, learn to survive. It will step right up, screech, won't shake your hand, just try to beat you. stakes get pretty high. You either do it or you die when face the fire.
Adjust the hose so there's no kinks. The radio's the driver, but the hydrant's hooked. It's ready for water. Okay, we've just got the go-ahead from the hydrant operator, and we're en route to the fire. Whether laying a line for yourself or for an engine at the fire, the process is pretty much the same. Pull up to the engine or the fire, set the brakes, and if it's for yourself, don't forget to engage the pump. Place the wheel chocks and place the hose clamp at least 20 feet from the tailboard and 5 feet from the coupling on the supply side. And go ahead and make the connections. Now, let's talk about nozzles and equipment. The 1.5-inch adjustable fog nozzles are the most common nozzles found on the engines. These nozzles can be adjusted to flow between 30 and 200 gallons per minute. But remember, our directives say that they need to be set at 95 GPM when these hose lines get repacked. An advantage these nozzles have over others is that they can be taken apart to create a 15/16 solid bore nozzle, or to extend a hose line. The 2.5-inch play pipe can either accommodate stack tips or an adjustable fog nozzle. The solid bore stack tips for handheld streams range from 1 inch to 1.25 inches, depending on GPM required. The 2.5-inch fog nozzle ranges from 125 to 250 gallons per minute. The other type of nozzles found on the trucks are automatic fogs. The 1.5-inch automatic fog nozzles are primarily used for trash lines, and their GPMs vary by pressure. For instance, with the engine pressure of 115 psi, giving the nozzle 100 psi, the GPM would be 100 gallons per minute. The larger 2.5-inch fog nozzle also depends on pressures to produce GPMs. For instance, at 120 engine pressure, with 100 psi nozzle pressure, it'll produce 250 gallons per minute, and you'll still find these in use today. For master streams, the solid bore tips range from 1 3/8 inches to 2 inches, and from 500 gallons to 1,000 gallons. The fog nozzle can produce 1,000 gallons a minute. All of the deck guns, with the exception of the remotely controlled deck guns, can be removed to be placed on the ground. Some of our engines are equipped with mercury monitor nozzles. These are 500 GPM nozzles that are designed for rapid deployment. They can be used with fog or solid bore tips and are pre-connected to a 3-inch supply line. Before we put everything together, we need to talk about hydraulics. This includes nozzle pressure, friction loss, and engine pressure. Directive 218 does a good job spelling out the required engine pressure for specific hose lines. But keep in mind, this is only a starting point, and you may be required to flow multiple lines or extended lines. The following charts can be used as quick references for nozzle pressure, nozzle GPM, friction loss for various GPMs, flows and hose sizes, and supply lines. And these charts will be included with your fire mod. Now, the basic friction loss formula is C times Q squared times L, where C equals the coefficient Q is the flow rate in GPM, and L is the length of hose. Now let's put this into practical terms. Let's assume you have 400 feet of 2.5 inch hose flowing 300 gallons per minute. What do you think the friction loss would be? In this example, 2.5 inch hose line has a coefficient of 2, so C equals 2. Q, or quantity, is equal to the gallons per minute divided by 100. In this case, 300 gallons divided by 100 equals 3. Therefore, Q equals 3. And L, or length, is equal to the length of the hose line divided by 100. 400 feet divided by 100 equals 4. Therefore, L equals 4. Now, let's put these numbers in the friction loss formula. C equals 2, Q squared equals 3 times 3, and L equals 4. Therefore, 2 times 9 times 4 equals 72. So the total friction loss for this hose line is 72 psi. Now, we figured out the friction loss for this hose line. What do we do with that? We need to add it to one more formula, the engine discharge pressure formula. The engine discharge pressure is equal to the nozzle pressure plus friction loss plus or minus elevation plus the appliance. Nozzle pressure is either 100, 80, or 50 psi. Friction loss is calculated for the individual hose lay, plus or minus the elevation, 5 psi for every 10 feet. And the friction loss for appliances can range from 5 to 25 psi. Now, let's plug these numbers together. With a nozzle pressure of 50, let's say, a handheld solid bore nozzle, friction loss of 72 psi, no elevation, and let's say there's no appliance in there, we simply add the numbers together. 50 plus 72 equals 122, which means that the discharge pressure would be 122 psi. In the event where you have a single hose line made up of two different size hoses, let's say 200 feet of 2.5 and 150 feet of 1 3/4, and you're flowing 95 gallons per minute through a fog nozzle, you would calculate the friction loss for the 200 foot of 2.5 flowing 95 GPM and the 150 foot of 1 3/4 flowing 95 GPM, and then simply add them together. And don't forget the appliance. When we talk about wide hose lines, we're generally talking about 2.5 inch or 3 inch hose into an appliance and two smaller hose lines to the fire. To calculate the friction loss for this hose line, simply take the total GPM and divide it by 2. Use that number to determine the friction loss for one of the wide lines. Then determine the friction loss for a larger hose line, using the total GPMs from both wide lines. Add these numbers together, include the appliance and the nozzle pressure, and this is your engine discharge pressure. For multiple hose lines of equal length, equal diameter, and equal flow, you only need to calculate for one. In the event you have multiple hose lines of unequal length, diameter, and flow, you'll need to calculate for each one individually. Set your discharge pump to the highest pressure and gate down the rest. To calculate the nozzle pressure for the pre-pipe master streams, use 80 psi as the nozzle pressure plus 25 psi for the appliance. To determine the friction loss where multiple lines are coming into the master stream, simply divide the total GPM by the number of hose lines supplying the device and calculate the friction loss for one of these lines. Add the nozzle pressure, elevation, and appliances. And that's your discharge pressure. Last but not least, how do we determine if we have enough water left in our supply to open up more hose lines? First, once you have a secure supply, before opening any hose lines, make a mental note or a mark of where the intake pressure is. Let's say, for example, you have 50 psi on the intake gauge before any valves are open. We take the first number and create a scale of times 1, times 2, and times 3. In our example of 50 psi, 5 being the first number, we would take 5 times 1, 5 times 2, and 5 times 3. Mark the intake pressure after opening the first hose line. If the residual pressure on the intake gauge drops by 5 psi or less, 2 more lines can be opened with the same GPM. If the residual pressure drops between 10 and 5 psi, only 1 more hose line with the same GPM can be opened. And if after opening the first hose line, the residual pressure drops 15 to 10 psi, no more hose lines can be opened. This concludes the pump operations presentation. We've discussed the different components of the pump panels, what they do, and how they're used. We've discussed the different nozzles used by Sarasota County Fire Department, their pressures, and their GPMs. We've discussed the friction loss formulas, the engine discharge pressures, and how to calculate for various hose lines. And we talked about how to determine if we can open more hose lines with the available water supply. Again, this presentation is intended to show the basics of pump operations. It is not intended to replace the hands-on training. For more information on pump operations and pump hydraulics, please refer to Fire Department Pumping Apparatus 7th edition by IFSTA, Pumping Apparatus Driver Operator Handbook 1st edition by IFSTA, the official student resource manual, Fire Service Hydraulics, located on the training website at www.scfdtraining.org, Fire Training Hydraulics. Or take the Fire Service Hydraulics or Fire Apparatus Operations courses, either at SCTI or at the Fire College. Thank you.